I guess we get started. Back quite a while ago at this stage, I had the pleasure of working on this project, the International Space Station project. I was working on the Canadian portion, which are these robotic systems here, working on the control software for that. What was particularly interesting about this as a project was that it involved all the different engineering disciplines. So you had your mechanical engineers, controls engineers, electrical, electronic, you name it. And I was always kind of envious of those guys because their world was very physical. They could look at what the space station was gonna look like when their work was finished. Okay? And you could look at their diagrams and you could see any schematic or diagram of the portion they were working on. If it looked good, then the chances are there was something right about it. In our world, however, we were dealing with this stuff. And you know, when you're working within code, you can tell when it's good, right? When you're looking at a class and you're looking at the methods and fields and how it's connected, you get a sense for the quality of the code for sure. And we had loads of tools for helping us do that. But yet, as the project progressed and the code base grew bigger and bigger, and we had many partners working on that, deadlines started to slip, and you got into the usual problems that you get with a large code base. And there was a sense that there was something else. Although the individual lines of code were looking good, there was something else going on that really wasn't visible. Okay? So what I want to talk about today is how you can expose the overall structure of the code that emerges from the individual lines of code and use that. And I want to focus not so much on things like metrics and the science behind it, but more just try and convey an intuitive feel for what it is that is good about structure. Okay? How do you recognize good structure? How do you recognize when it's starting to deviate as you change the lines of code? And how can you kind of get it back on track? Okay? So the first thing we're going to be talking about for sure is exposing structure. Okay? Something that's not visible right in the code, okay? And when we expose that, it may or may not look beautiful if you haven't been doing it before, okay? Yet, when you do expose the structure, warts and all, you now have a chance to kind of proceed and progress and to get something that looks beautiful at a distance, and more importantly, in a sense, not only does it look beautiful, but your team is going to be a lot more productive for working on it, okay? So how do we organize code? What are the structures that we use when we're developing code? First one, obviously, is we don't just throw all our code in one big file. You've got a million lines of code. You're not going to have it all in one file. You're going to organize it into files. So in an OO language like Java, you're going to put it into class files, where you pull together a bunch of methods and fields that are kind of in some way related, and somehow now we can understand this class a lot better than we could if it was just several thousands of lines perhaps of code. Okay? We now have something that already I'm starting to feel that that's kind of understandable, and we can now understand many classes and how they relate to each other. Okay, so we're already starting to, pull together some sort of system. Whether or not you actually see these is another matter, right? But at least in your head, you're seeing this as you're starting to understand the code in a project that you're starting to work on. Okay. But it doesn't take very long, of course, before your class diagram thing, right, starts to look a bit like this, where you may well have thousands of classes, all interdependent, all dealing with each other in different ways, in a way that's actually very hard to understand. Okay? There's too much detail here. We need some higher level constructs. And of course we do. We organize our code, right? We put it into packages and Maven projects and assemblies and you name it, okay? The question is that really what we want? So let's look at this and say this is our structure, okay? So if I just made this a sort of 2D representation of the tree view where you can see there's a nesting of packages going on here, okay? And what's really interesting is not so much this is the compositional breakout of a project, but what are the dependencies between those components, okay? And if I look in close at that, this is what I will usually see if I haven't been monitoring the dependencies, okay? If I haven't been looking at the structure in any way from the start of the project. I'll almost invariably see something like this, which is, to put a phrase on it, I suppose, is a big tangled mess. Okay? Now, why should we care? Let's talk just for a minute about the sort of things that a good structure can help us with. Okay? First of all, it can serve as a map for developers. It helps them understand how the code hangs together, and when they're working on it, where should they be working? Where should they add new stuff? Where should they find stuff? Okay? And not only that, but behaviorally, how does it hang together? Okay? Phased development, right? When a project gets bigger, you tend to have more and more developers on it. You may have different teams and so forth. You want to be able to phase your development so you sort of work on some items and kind of get that to a point of releasability, if you like, and then the consumers of that item can now start working on that, okay? And do a bit more development, do a bit more testing, check it in for the next guys to pull in to theirs. If everything uses everything, you can't do that, okay? To divide the work effectively, okay? You can't divide the work amongst individuals, amongst teams, organizations, if everything's very highly coupled, okay? It's just not going to work. Modularity, information hiding, all those structure or software engineering 101 kind of concepts that we learned about, they all kind of flow from a good, cogent organization of a code base. Okay? Reuse, replace subsystems. You can't reuse or replace something if it involves the whole code base. Okay? It's just not possible. Okay? Regression. What's going to get impacted when you make a change? Is it going to affect, you should know really before you make the change, what are the other components that could get impacted by this change, etc. Now, really what you want there is something other than this, okay? If you want these things to be a reality, you need something that is other than that. So let's sort of look now at what that might be, okay? I'm going to talk about some of the aspects of structure, just some concepts, really, that I'm going to sort of start building up a picture, I suppose, of what is a beautiful structure, okay? Containment is a key one, okay? Again, we've sort of touched on this, you need containment. Containment is part of how we abstract, right? We take some lines of code, we put them in a function, right? We call the function with parameters. That's containment there. We have to do that, otherwise we haven't a hope of understanding complexity. Okay? This is why we don't do assembler language anymore. Apologies if anyone here does assembler language. So what we mean by containment is you pull together a few methods and fields, you put them in a class. You take a few classes together and you put them in a package. You take a few packages together, maybe a few more classes, you put them in a higher level package, and etc. And you repeat and repeat. And that containment structure gets deeper as your code base gets bigger. Okay? A kind of a concept that I like to use with containment is, when do you have enough containment? Okay, how do you measure containment? When do you have a lack of containment? Well, if a million lines of code in one file, that's a problem, right? Well, what about 16 classes in a package? Is that okay? Or 60? Or when is it a problem? Okay. What I tend to measure myself, and in a sense you don't really need to measure these things, it's more as you're looking at the code, be aware of them. There's a concept of cyclomatic complexity, which goes back, I think, to the 70s as a metric for how complex is a function. Okay? And rather than measuring the number of lines of code, McCabe decided that's too simplistic. What you need to do is measure the number of possible paths through that function. Okay? That's so I could have 100 lines in a row, and that's actually anyone can kind of go through and understand that. You might argue that there's a certain benefit to chunking some of it out, but it's not at the end of the world. If I've got very deeply nested control structures, for loops, while loops, conditionals, etc., where there is 50 possible ways that the control flow can go through that function, then that's much harder to understand. Okay? And I'm going to want to, even though it may not be a lot of lines of code, I probably want to take out some of those nested blocks and put them somewhere else so that a human has some hope of understanding it. Okay? Similarly, with containment, rather than measuring the number of items in a container, I would say be aware more of the number of inter-item dependencies, okay? Because that's what's driving up the complexity. That's where you require the intellectual effort for the developer to understand, okay? So try and keep that under control. Okay, containment is part of it. The other major part is dependence, and in particular, how does dependence and containment interact, okay? So very simple, really, but when you're making a change to the code, like you add in a call into the depths of the code, you could be having a very significant change to the structure of the code base when you do that, okay? Why is that? Well, you could actually be causing, at the very top level of 1 million lines of code, right? And each one of these is 100,000 lines or something like that. They're major components. You could be creating a brand new dependency between the very top level components of the code without really knowing about it. Very easy to do. Happens all the time, and that's why we end up with a tangled mess, okay? Why is that? Well, it's quite simple, really. What you've just done is you've created a call from that method to that method. Okay? At the same time, you've created a call from that method to the enclosing class and to the enclosing package and the enclosing top-level package. And not only that, but you've created a dependency from the enclosing class here is now dependent on this package. Okay? And that package, inner package there, is now dependent, etc., all the way up to the top. So that's how dependencies and containment interact. Okay? And that goes both ways. When you create a dependency, it creates dependencies between the containers higher up. When you move things around or put them in different containers, that can have a dramatic impact on the overall structure. Okay. Levels. Okay. So this is very much related to dependencies. Levels is quite a simple concept. You're basically anything that depends on nothing else in a particular scope. So we're looking at the contents here of a package. Anything that depends on nothing else, we're going to put on the bottom level, okay? And these things here, they're on the bottom level. They don't depend on anything else, including they don't depend on each other. We're just going to put them at the bottom. And then anything that depends on these items, right, goes on the next row. Okay? And likewise like that. That's levels. Just think of your code base as levelization, okay? And you keep doing that all the way up. Not only that, but you do it at every scope, okay? So here you've got, I've expanded here. You can see that inside this package here, this one's expanded. This is levelized. So there's two subpackages here at this level, this one and this one, okay? And then next level down is this, next level down is that. Within here, this is also levelized. Okay? You might notice that I've removed the dependencies from this diagram. When you're thinking in terms of dependency levels, you can actually spend a lot of the time not worrying about individual dependencies. Okay? The levels themselves are derived from the dependencies, so you don't need to get into that detail all the time. Okay? Next thing to be aware of is that dependencies are cumulative. when you depend on an item, in a very real sense, you depend on everything that that item depends on. John Lakos defined this measure, which again, it's not something that I would necessarily measure all the time, but it's a way of thinking about a code base, called cumulative component dependency, CCD. Okay. Very simply, it takes a levelized chart like this, and it assigns a number to the bottom row, number 1. Okay. Then you go up the layers, and you assign a number to each item in your graph, okay, which is the sum of the items that it depends on plus 1. Okay, so 1 and 1 is 2 plus 1 is 3. Okay, up at this level, it's 3 and 3 plus 1 is 7. Okay, and then you sum all of that up, and that's a number. Right? The importance of that number is that it is a real measure, a really good measure, I think, of the overall connectedness of a bunch of items. Right? So when you've got a bunch of items at a scope or whatever, this is a measure of the overall connectedness. Okay? The bigger the number, the more complex is that collection, particularly of software items. Okay? And complexity is bad news for impact. Right? Well, the more connected is a code base, the more impact you can expect when you make a change to a particular code item. Okay? Let's look at that a little bit more, a bit later on. Another concept to just kind of mention is the locality of dependency, and that's very simple. These items here are locally dependent. Okay? They depend on something that's in the same locality, in the same package in this case. Okay? That's a bit less local. That's going outside of my immediate package and depending on something at my parent scope, grandparent scope, great-grandparent scope, etc. Okay. So, based on those few concepts, let's look at what we mean by beauty in a sense for structure. First thing we're going to need to look at is containment, and when do we have enough containment? And I already talked about using the kind of CCD or the cyclomatic complexity concept when you're looking at containment. And here's a package with some classes in it and the dependencies between the classes. Okay, so that's a lot for anyone to try and understand. Okay, much better to divide that up into sub-packages that look more like that. Okay? So I'll talk in a while how you might do that. But that's really the concept. You just need enough containment so that every time you expand an item or you look inside a package or a class or a Maven project or whatever it is, you should just see a breakout at the next level that you can understand. Okay? If you see 1,000 things at the next level, well, okay, whatever. Okay? But the containment isn't helping me in that case. Next thing, acyclic container dependencies. The dependencies between containers should be acyclic. Okay. Now, let me see why that is. Let's look at the CCD of this acyclic arrangement of whatever they are. Okay, packages or classes or whatever. Okay, that's acyclic. Okay, its CCD is around 164. Okay, we've added here a single dependency from the bottom to the top. In this case, all the dependencies are flowing downward. Now that means that this guy here, near the bottom, can only depend on a few items below it, okay? This guy here can only depend on a few items below it, okay? Now, when I've got a cycle here, there is no below anymore, right? Because below brings me back up to the top, okay? I call this a structural go-to. Right? This decimates your structure in the sense that it makes it extremely more complex and at the same time much harder to understand, and you lose all those ilities when you get one of these things. Okay? This guy's CCD is now an order of magnitude higher. Okay. Let's look at a slightly more, less mathematical view of it. Here's an arrangement of a bunch of classes, okay? And I can see here that, test libraries, I can explain this. I've got a new guy joining the project. Man, you got this test library. I can draw it on a whiteboard or something like that. Test libraries is the main driver of my application, and PNUnit, does a bit of logging here, and then it uses NUnit for such and such. And then NUnit kind of uses CP to do a thing, and then fit to do something else, and coblast and colors. And I've kind of explained it, right? I can explain this diagram quite well. This is the exact same code base organized differently, right? So I've just moved the classes around into different packages, right? Now trying to explain that, okay? Where did we start? Test libraries. So I can say, well, test libraries uses NUnit, and NUnit uses fit for something, but fit uses NUnit for something which kind of might come back to fit again. And then NUnit uses CP, which uses test libraries, and NUnit comes back to, I'm all over the place. Back up to PNUnit here, back down to test library. I can't really explain that. I can't understand that as a flow, right? That's not a design. That's not beautiful anymore, okay? The thing on the left is really easy to understand, okay? Thing on the right, much harder to understand, and actually much more complex to work on, okay? Keep dependencies local. Okay, why do I care about locality of dependencies? This comes to the familiar concepts, I guess, of cohesion and coupling. When dependencies are local, relatively local, you're going to have higher cohesion within containers and lower coupling without containers, right, beyond containers. Okay, so what does that mean? Here's two packages expanded. There's one there, and there's the other one there. Okay, and they're sitting within a couple of other packages. Don't worry about that. But you can see here that this dependency, this grouping here, right, and this grouping here, they're on the same row, so there's no dependencies between them. Okay, this is very low cohesion within this package. There's also a lack of cohesion within this package. Okay, got two separate groups that don't depend on each other. And if you look at all the dependencies here, one of the dependencies here is local. Okay, but most of the dependencies from this package here go outside of the package to here. Okay, again, it's like much harder to understand that. I want to just be able to look at one area and understand how that works without jumping all over the system to understand how it works. Much more powerful, simple human psychology to be able to understand something in and of itself. Okay? If I slightly rearrange those packages, I now have two cohesive packages. Okay, same packages here, just with the content sort of moved around a wee bit. And here I see that this package here and this package here are both nicely cohesive, okay? And actually there's no coupling between them. Okay? This is a much better arrangement in this case. Okay? Narrower interfaces. Yeah, just a quick word on this. This is to do with information hiding. You can see here that this package here and this package here are both used from outside of the parent package. And what I mean by narrower interfaces is, like when you're working on a class, you kind of explicitly say what's public and what's private. We tend to forget about that at the package level, partly because, it's partly supported in languages like Java. C# doesn't support it at all, I don't think. So it's quite easy to forget about, and it's quite easy to change, and it's not as visible. So it tends to get forgotten about. And then when you've got packages themselves, you can't say this is private. This whole package, I want this to be private. This is an implementation package. No one outside should be using this package. Okay? Be aware of that. And try and keep it narrow. Right? Don't make everything public. Right? If you saw a class with everything public, you say, well, that's not right. There's something wrong here. Everything shouldn't be public. There should be some internal stuff that the guys from the outside don't even need to know about. Okay? Same idea. Lower level dependencies. Okay? Co-location based on codependence. Now, what I mean here is, if if you see that package at the top there, most of its dependencies are down here, somewhere near the middle of this levelized dependency graph, okay? But there's one dependency way up here, and that's holding this whole package up here, okay? If that dependency wasn't there, it would be able to sink down, lowering the CCD, okay? Because when I'm dependent on this, that means I'm dependent on at least one thing on the next row down, and etc. Okay? So think in terms of it may well be, and I'll show you this later, may well be that inside here there's just one or two things that need to use this, but actually the rest don't. Get them out of there and let that sink down to its natural level. Okay? We're working towards all the time reducing coupling. A levelized dependency graph, which is flatter and thicker, is much less dependent and less complex than one that's more vertical. So all the time, try and keep things coming down, because it's only dependencies that push things up in a stack. Okay? Final word on restructuring here. You will, as you expose structure in your code base, you'll want to start changing it, okay? There's a real temptation to see, well, oh, this thing here is causing a cyclic dependency. I have to change the code so that it no longer creates this feedback dependency, okay? That is often the wrong approach. You have to, first of all, check that your composition is right, okay? Is it depending on here, and is that the problem? Or is it that actually this class should be in a different package, right? Is the composition correct? Get that right first before you start monkeying around with your code, creating interfaces, making things more complex even, to try and make it fit an arbitrary containment structure that just grew accidentally over time, okay? Second step, you may need to do some refactoring, okay? But recomposition is a much lower risk, right? You're just renaming things, really. Okay, so from a point of view of keeping the integrity of the logic of the code, you're much better off just to move things around than you are to change the logic. Okay. Okay, so what is it that? Why does this not happen? So I actually went back and found a nice collection of builds of the FindBugs open source project, okay? So not to pick on these guys, but they just happen to have lots of builds over a period of about 3 or 4 years of the code base. And I said, well, let's look at the top level breakout of that code base over that period of time and see how it evolves. And actually you could do this with pretty much any project where nobody is monitoring the package dependencies, okay? So this is how it started way back in March 04. Next release, you can see that it's grown considerably. But again, in terms of describing that, there's no cycles in it. It's quite easy to kind of guesstimate, knowing nothing about the code. If I wanted to add a new bug check of some sort, I could probably figure it out from here, okay? You know, FindBugs uses BA. Guessing that's bug analysis. Bug analysis has a graph model, uses a graph model somehow of the code, probably within the syntax tree. Annotations is used as well, and graph uses the annotations. Okay, I can understand all that, that's good. Okay. Now, at some point, FindBugs and config, is there a config here? There's a config here which is nicely dependent on FindBugs, okay? At this step here, config and FindBugs became somehow or other completely intertwined, right? The weightings here are the number of code references between these two packages, and you see it's kind of balanced, okay? So that's it's not the end of the world, it's only 2 packages, okay? But here we have now BA has been sucked in. Now, this looks like, this is in fact quite a chunky class here, a chunky package. A lot of stuff goes into BA. And it looks like just a little accidental weighting of 2 dependency back to FindBugs, where there's 186 the other way. Okay. And filter was pulled in as well. Okay. So it's starting to get more complex now. Okay. Ooh, okay. BA to FindBugs now has gone from that 2 has now become a 99. And that will happen. right? As soon as you get a rogue dependency somewhere, the programmers will follow those dependencies and they'll tend to grow, okay? You're starting to lose your abstractions here, okay? I can still explain to someone, I guess, how this is used, but it's kind of like, I don't know, props uses a bunch of stuff here, and then it uses graph and annotations, and visit class goes through all the classes which use. But when I try and describe this bunch of stuff in the middle, that gets quite hard, okay? It's hard to understand, it's hard to work on. And that just kept growing, okay? It's like a black hole, it just sucks everything into it, right? Tangles are just, they're evil in that sense. So how do we keep things beautiful? Well, first thing you're going to need is probably to extend your tool set, okay? You're not going within a normal IDE to be able to see these higher level structures as easily as you need to, if at all, right? If you're working on 100,000 lines of code, you can't understand the structure by looking at 100,000 lines of code, okay? Not possible, okay? You need something else, okay? You need something that is going to parse the code, right? You don't need Visio, right? You need something that is going to look at the code and construct some sort of hierarchical dependency model. So you want to see what I've been showing you so far, really, where you see the composition, you see the dependencies, you can drill in to find out the reason for those dependencies, okay? Going to need that. And it should be malleable, right? You should be able to move things around to simulate changes to the composition and see how that affects the structure. Some options for you. Sonograph has these kind of diagrams here, does all of those kind of things there. Other tools that do that kind of thing, but using a matrix representation for the dependencies, okay, is Lattice and IntelliJ. And what they do here is basically if they have all of the items at any scope or for whatever exposed scopes you have, there's a number here in the cell between the row and the column of the intersection of those items. Okay? What I'll be showing you is Structure 101 now in a moment, because I've been working on it for 10 years, so I'm most familiar with it. And it uses this LSM, levelized structure map, is its primary glue here. It also does a bunch of other things, so you can export action lists when you figure out some changes you want to make for refactoring. You can define architecture diagrams, share them with the team, all kinds of other cool stuff, but I'm not going to show you any of that today. I'm just going to show you the LSM to try and kind of convey, I suppose, the basic principles we've been talking about around structural beauty. Okay. So on that now, I will jump across to here. Okay. This is actually kind of I've monkeyed around with it a little bit, but this is the Spring code base. Okay, top level breakout of the Spring framework. Not sure if it's the current, if Jürgen's around. I'm sorry if this is this is probably an old one, but they've been consistently monitoring package dependencies in the Spring code base since the beginning of the project. And you will get no cyclic dependencies between packages in the Spring framework. What does that mean? That means I'm looking here, all the dependencies flow downward, okay? If there were any feedback dependencies here, you would be seeing those little red boxes of tangles. I'm not seeing any tangles here. So I can kind of look at these. If I select one of these items, there's the dependencies there. It uses remoting. Remoting uses web. I can have that narrative about how the system hangs together. Okay. When someone changes something down here, expression changes, what are the packages that could get impacted? What is the closure of the packages? Well, that one nothing uses cache, okay? JDBC context might change. Oh, quite a lot of things. I can have those kind of conversations, and they stop, right? Looking at the closure of the dependencies stops somewhere. It doesn't get into a loop that goes on forever, okay? The other thing then is not just at this level, is everything nice and tidy, okay? But I can drill into JDBC, okay? There's a nice mine-sized chunk of packages in here, acyclic. You can cite core, okay? I can look inside support. Hold on, let me just do that. Okay, there's a bunch. Now we're down at the class level here, but there's some classes and there's some packages down at this level. Sorry, the mouse has just been captured. Okay. I can look inside context. And I can look inside JMX. Anything I look inside, I'm going to basically see the same kind of thing. I'm going to see not too much stuff, right? It's not too fat. It doesn't have a high cyclomatic complexity of relationships between the next level breakout. I can kind of understand it at the next level. And I'm seeing no cyclic dependencies between the packages. Okay, that's great. Now, as I'm working on this, I may well decide that, well, you know what? Let's say that I want to make a code change that's going to create a dependency between these two packages here. Okay? What's the impact of that going to be? Right? Well, let's simulate that. I'm going to expand those two packages. I'm going to span down, find a class here. And let's say I make a call from response entity to aspect J async configuration. Okay? So I'm going to add a dependency from response entity to that. Okay? And let me just collapse those for a moment. Let me just have a look at what happened there. Okay? So you can see here, where if I do an undo, right? Here, HTTP and scheduling are on the same row. And all that happened there was, if I redo, HTTP now moved up above scheduling. Right? Now, what's the impact of that? It's not earth-shattering, right? It does mean that my CCD went up a certain amount, okay? Because now anything that uses HTTP, and because HTTP is the only package on its row, I know that everything above here, either directly or indirectly, flows through HTTP. So all of those things now use scheduling, right? Whereas before, not all of them used scheduling. In fact, none of them used scheduling before. Okay, so I've pulled scheduling in, not just for me, but for everything that uses me. Okay, but anyway, not ugly, not unattractive in that sense. Okay, what about now if I create a dependency, however, from somewhere inside context here to somewhere inside web? Okay, so let's say that this load time weave aware thing uses Spring Servlet. So select those two. Add a dependency, load time awareness. Ooh, what's happening now? Okay, let me just collapse those away now and see what we ended up with. We ended up with a red box here. This is a tangle in our parlance. Cyclic dependencies, a bunch of packages that are now cyclically dependent where they weren't before. Why is that? Okay, so you can see here, if I undo, right, web depends on a few things. What depends on, oh, sorry, collapse that. What depends on context, okay? This thing OXM, HTTP depends on OXM, web depends on OXM. So what I ended up with was a dependency from web to HTTP to OXM to context, which was there before, and now I added in one back up to web. So I'm going round in circles now when I do that, okay? Like that. Okay, so that would be something I'd really want to know about. As if I was Jürgen and someone had put in a build, I'm sure he gets an automatic notification that, oh, something's wrong there. In fact, the programmers, I bet you, never put those in because they get notifications as soon as they make the code change. Okay, but that is something that unless you're looking at it, it won't happen. And you're moving towards that big tangled mess right there. Right? That's a go-to, right? And go-tos breed, okay? Okay, so that's the first one. The next one, let's go here. Okay, different situation here. This is a situation where I've got a whole heap of stuff in a package. This is just, we're just looking at the contents of one package here. Okay, let me simplify the picture a bit by getting rid of all the names. And you can see here, if I drag that across, this is an expanded package, leaf package here, with a whole heap of classes in it. Okay. And I say, well, that's too much stuff. How could I take this overly complex lack of composition situation and improve it? Okay. Well, what I want to do probably is create a bunch of subpackages here, right? Take some of the classes, put them in a subpackage. How do I do that? Okay. Well, one way I could do it, I suppose a very simplistic way, is take it layer by layer. Okay. I go like that. I'm just going to wrap it. Where's my wrap? Did my wrap. Just give it a random name. Okay. And then take the next row. Wrap that. Wrap. ZZ. Okay. Okay. So now I'm creating a package structure, a row at a time. Okay. And I know that's not going to be cyclic because I'm just taking a row, next row, next row, next row, and it's already levelized, so that'll definitely not be cyclic. But that's not the end of the story, right? Because we need to look at the locality of the dependencies here, right? Coupling and cohesion. And what do I see when I expand those packages? I see that I've got 4 classes inside here that are totally not cohesive. They don't depend on each other at all because they came from the one row. Things on a row don't depend on each other, okay? All of their dependencies are non-local, and that'll be the case all the way down. So that would create, if I did that, that would be a terrible structure, okay? No, what I need to do is look at this overall set of classes and try to pull together things that are related, both in the sense of they relate to a theme of some sort, and they have dependencies between them, okay? That's what I ideally want to do. So I'm going to undo those two. And now I'm going to look at the names again. And let's just take it random. So what I would do is take something like checkbox and this abstract single checked element here, for instance, and I would wrap those two into something maybe called check tag. Okay, there's my check tag stuff there. And what is it using? Oh, it's got something over here, right? It's got something called abstract checked element tag. Move that there. Okay, that's good. Anything else? Oh, here's another check tag related thing. Move that in there, etc. Okay, and what I'm doing here is I'm pulling in, as I'm going, making sure I don't create, as you get several packages, you'll get a warning immediately from the levelization getting broken and a tangle appearing if I create any cyclic dependencies, but I'm pulling together things that are cohesive, okay? So that's good, okay? So what I would do is continue that kind of process really until I get something like, let me just undo a few times here, and again, so I'm going to get something, the names are immaterial at this stage, I guess, until I get something like that, okay? So this is my original ocean of classes kind of structure here is now improved to the point where I can see each one of these, I can understand them, they're acyclically dependent, this is nice, this is much more beautiful, okay? I like this. Okay? And if I've already done that to one level, okay, there's still going to be a lot of dependencies here because there's quite a lot of packages here, right? So there's quite a lot of sub-packages within this. So I can repeat, okay? I can repeat it again. So now I've got a mixture of packages and classes and stuff at this level here, okay? Okay, so I just take the packages and I put the packages in packages, and now I've got this sort of little hierarchy of classes, which is nicely structured, okay? Better than the big fat alternative that I started with, okay? 2, coupling and cohesion. Just show you a couple more things and then I'll wrap up. I guess the time is more or less due at 20 past. So. Okay, let me switch on this little option here. This just highlights the disconnected groups, okay? So you can see here, this is the picture I had in the slides where you've got 2 groups here that are not connected at all. I've got all the dependencies are flowing out of this package into this package, okay? And I can see this grouping here is heavily used by the items in this package, okay? But actually doesn't use any of the other items in this package. That just shouts out, when you see that so clearly, shouts out to move that up there, okay? And now I've got a cohesive group of stuff here, a cohesive group of stuff here, and no cohesion between them. Simple as that. It's a rename, bunch of renames. And now the guys working on this area are going to find it so much easier, right, to understand the structure, and that'll help them with their development, okay? I think there's one or two more I had. The narrow of interfaces, one here, okay? This is where I can see here, I've got, you know, this package here is being used from the outside, and these two sub-packages are being used, okay? Now, when I expand this sub-package, I can see that what's being used in here, let me switch that off for a moment, is just this single class here, okay? And when I select that class, I notice that it isn't being used by anything else inside this package, but it is being used by stuff in this other package that is already visible from the outside. It's already being used from the outside. So I'm just going to take that class and move it into that package. And now what I end up with is a single package that is used to access a bunch of packages, right? The work being done by a bunch of packages. Much easier to understand, okay? Now, in Structure 101, what I do is I make an architecture diagram and say, these are the ones that are private, hide them, okay? But that's the kind of next step. That's enforcement, okay? Okay, what else? Was there one more? Lower level dependencies. Okay, this was another kind of nice sort of little mini use case, if you like. Here I've got that situation I showed before where there's a dependency here that looks sort of out of place, right? This package here is being held at the top level of the layers of the levels by this dependency here, okay? And if I look inside here, I see that dependency there is just coming from this one package here is dependent. The rest of the packages only depend on things way down here, okay? Now, can you see what will happen at this stage? You might be able to kind of guess what will happen if I move this package into this package, okay? What will happen is that the rest of these packages, the rest of this package now no longer has a dependency up here, okay? And it'll just sink down to somewhere around about here, okay? Because there's nothing left to hold it up. Let me do that. Doosh, down it goes. Undo, redo. That one, you know, movement of a bunch of classes, so it's a bunch of renames. But now I've got a structure with a lower CCD, right? Lower center of gravity. This is great, okay? You know, just something that's a bit more easy to work on. There's going to be less impact at the package level when I do that. Okay. And that, I think, is about it. I think we're more or less out of time. So let me just go back to my final slide. And if there are any questions, I could take those. So, any questions? Okay. If there's no questions, then thank you very much for attending. And talk to me after if you do have any questions. I'll be around for a little while.